All right, Algebra 1 students, you know I'm missing you in Mexico. All right, I'll see you tomorrow. For today, we're going to be, the lesson is Introduction to Quadratics. So when you're done, you want to be able to identify the properties of quadratic functions. And here we start with a function we know very well, right? A linear function. So let's think of some vocabulary with both of these. So right now we know this is a linear function. What do we know about it? That it has slope, right? Slope. M equals the change in y over the change in x, right? M equals y over x. I should say change in y over change in x. That's a slope. Every line has a slope. Every line has a y-intercept. Y-intercept, which we know is b. Right here we have m, and here we have b. And the one thing that you can identify a line in an equation, it has an exponent. The variable x has an exponent of 1, right? It's to the first exponent of 1. Okay, so we call this the linear family. The shape is a line. And we know we've got a couple different equations, but our main one is y equals mx plus b. So we know point slope form, we know, I'm thinking of the other one, but ax plus bx equals c. So there's different forms, standard form and point slope form, but this is our main one. Now let's contrast that with today's lesson, the quadratic. Okay, so we're going to label this as a quadratic function. This is going to become your new best friend here. Quadratic function. And let's think about its characteristics. First of all, the most important characteristic is probably right here, and it's the vertex. Okay, and it is the vertex is always hk in the equation. We remember with exponential equations, we had an h and a k. Every function has an h and a k in essence, and this one, that tells us the vertex, hk. So there's a point here where the graph was decreasing, 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 and at the vertex, it starts increasing, increasing, increasing. Another important characteristic of a quadratic is this line right here. Imagine you can't see it, but if I draw a horizontal line straight through the vertex, then this is called the axis of symmetry. And we see it. We see the symmetry across this line. And this line, as all good lines, has an equation. And it's x equals, well, we know what the h value is because there's the h value, right? The x value. So the line is actually x equals h. And in this case, x equals 0. A vertical line where the only x value is 0. Y goes from infinity to negative infinity, but x is always 0. Okay? So, let's look. Function family is quadratic. It is a parabola. This shape, this U shape, is what we call parabola. And we can put in parentheses, U. Its equation is, I'm going to give you the vertex form, okay? And so the equation is y equals a times x minus h squared plus k, okay? So what we see in the difference between the line and the quadratic, the line has a power x to the first power, where a quadratic has x to the second power. That is the key difference between a line and a quadratic. Okay? Special properties of a quadratic. It has a vertex at hk. Right? The vertex is the midpoint of the quadratic. It is either a max or a min. I'll show you what I mean by that. Right? It's either a maximum if the parabola were facing downward, then the vertex would be a maximum. But it also could be a minimum, right? In the case up here that we have pictured, because if the parabola is facing up, then the vertex is a minimum value. It's the lowest y value on this parabola, where this maximum is the highest y value on the parabola, max and min. The axis of symmetry is the equation is x equals h, and it divides the quadratic in half. And there's perfect symmetry. It reflects like a mirror. There is reflection over the line x equals h. Okay. Now, just like with a line, we had 3 forms of a line. We're going to have different forms of a quadratic. This is our favorite. It gives us the most important information, the vertex. This is therefore called vertex form. We're going to get into this a little bit later, more into it. But right down here, we're looking at in our notes, where we're moving along, y equals ax squared plus bx plus c. This is called standard form. There is a third one coming down the pike. Standard form of a quadratic. Okay? And we know it's a quadratic because it's x squared. Okay? So that's the key feature of quadratics. Right? And here's what we also know. If a is greater than 0, positive a value. A is always the coefficient in front of the x squared term. If we have a positive a, then the graph faces upward. The graph faces up like that, right? And contains a minimum. And you're saying, well, doesn't everything have a minimum and a maximum? But let's think about this. If we have a quadratic, there's the minimum. That's easy to see. But these are arrows, right? They go on up to infinity. So we have a minimum y value. It contains a minimum y value. And then let's look what happens if a is negative. If we have a is less than 0, negative a, then the graph faces down. The graph faces down. Okay, so it's going down if it is negative. That's kind of intuitive, right? And if the graph faces down, then the graph contains a maximum and not a minimum. Contains maximum value. There it is. It's easy to see because that's the maximum value, but these arrows tell you on to infinity. Okay? So these are the basic characteristics of a quadratic. So if you need to, you can ask Mr. Raymond to show you these again. All right, we're going to go to flip the page. We want to talk about the domain and range of quadratics. We're all about quadratics today. The domain of every quadratic, y equals a times x minus h squared plus k, is numbers. Or we could say negative infinity to positive infinity. And we see it, right? No matter what, these are arrows, so x goes on forever in both directions. The graph will exist for any x value, okay? But the range is different. The range, looking at this graph, the graph exists at -4, but it doesn't exist at -5 or below. So the range is connected to k, okay? If a is positive, remember, if a is positive, let's do a little sketch. A is positive, then the graph is facing up, right? And what we find is we have a minimum y value, and our range will be all y is greater than or equal to k. It does exist at -4, but it doesn't exist anywhere below -4. And Well, what is negative 4? It's the y value of the vertex. This vertex is 2, negative 4. So we see that the range is dependent on the k value. Let's look at this real briefly. This quadratic has a vertex of negative, negative 3, 2. Negative 3 is the x value, positive 2 is the y value, so the range is going to be connected with the y value, or the k value. All right, so back up to our notes. If a is positive, y is greater than or equal to k. The graph exists greater than or equal to k. But if a is negative, then we have a graph that's going down, right? Y is still connected to k, but y is less than or equal to k, right? And that makes sense. All right, let's look at these two quadratics and state all their characteristics. So we've already determined the vertex. The vertex is 2, negative 4. The axis of symmetry, well, we said that was x equals h. So we go to the vertex. Remember, this is hk, so x equals 2 is our axis of symmetry. And let's draw that. So at x equals 2, we're going to draw a dotted line because it's invisible, but we know it's there. This is x equals 2, and it's a max or minimum. Well, we have a minimum. A positive or negative? A is positive. A is greater than 0, positive. Concavity, that means up or down. This is up. Domain, all real numbers. Range, y, it's facing up, is greater than or equal to, where's k? Oh, there's k, negative 4. Okay, y is greater than negative 4. All right, there we have a parabola, a quadratic with a is positive. Let the quadratic where a is negative. We've already determined the vertex, the middle point. It's negative 3, 2, and let's label it h, k. Those are so important. Axis of symmetry. Well, the axis of symmetry is going to be x equals h, negative 3. So I'm going to my picture, and at negative 3, I'm going to draw a line straight down. And I'm going to label it x equals negative 3. Okay, and I'm going to pinpoint the origin. This is a little bit hard to read. 0, 0. There's my graph. Okay, my vertex is shifted left and up. Okay, max or a minimum. We see that we have a maximum because the graph is facing down. Because the graph is facing down, we know that a is negative. Concavity, down. Domain, all real numbers, negative infinity to positive infinity. And you see I'm writing it either way, okay? Range, well, it's all about k. What is it, greater than or less than 2, which is this graph is less than or equal to k. I is less than or equal to. All right, talk about the calculator. The calculator end right now. And you might want to stop the. So clear your do, and then you can go through the other examples one by one. Example number 1. We're going to type, so hit the y equals key, clear out whatever you have in there. There's our yesterday. All right, I'm looking at example 1, and I'm going to plug it in. 3, now I'm going to hit the graph button, and I'm not getting a good picture of the graph. So what I can do is what's called the graph is facing up. I know I can do one of two things. First of all, let's try to get a zoom 6 window, 10 window. I don't have a 10 by 10 here. So everybody hit the zoom 6 button and the 10 by 10. There, that's enough. That's good enough. And now I can see the vertex, but you know, it's hard to read on the calculator sometimes. Let me put the lamp on so you can see better. Yeah, sorry about that. It's even for me, it's hard to read that. So I can use the calculator. I see that it's a minimum. Okay, but see exactly what it is. So here's what we're going to go to the calc button, which is right, the calc is in blue. It's a blue key. So I hit the blue key, calculate. I want to calculate a minimum. I know it's a minimum because it's facing upward. So I tell the calculator, calculate this minimum. Enter, so second calc, I enter on 3, and then the calculator says, Ms. Craft, please give me a left. So what it means is, using these, hit the left arrow key, left, 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 and it says, show me what a left boundary, left of the vertex you're trying to discover. So I hope you can see that the vertex is here, and I have moved the cursor to the left of it, and I'm going to hit enter. And then it says, Mr. Kraft, can you give me the right bound? Such a nice calculator. I'm going to take my right cursor and right, until I am clearly to the right of this vertex, and I'm going to hit enter. And then it's going to say, give me a guess. I'm just going to hit enter again. Okay, so it's left bound, right bound, enter, enter, enter. Left bound, enter, right bound, enter. It's telling me the vertex. Okay, and what it's telling me is negative 0.666. Okay, the y value is negative 8.33. There is no way I could have determined that just from looking at a calculator. So we need the calculators. Okay, so let's what have we learned? We've learned that the vertex is at 0.667, 6 repeated, comma, negative 0.3 repeated. There's our vertex. It's not pretty. Now what do we know? We know so much with that. This is h, this is k. So we know the axis of symmetry equals h, so x equals negative 0.667. We know that we have a minimum because the graph is, a is positive, so the graph is going up, right? So we have a minimum. A is positive, A is the 3, B is the 4, C is negative 7. So A greater than 0, A 0. Concave up, domain all real numbers, range, okay, up. So Y is equal to K, negative 8.3 repeated. All right, so we'll do one more together. You guys can do the next two on your own. So looking at the second equation, go to y equals, clear out your first equation, and we're going to input the second one. We have now negative 2. When I have a negative and it's not subtraction, it's just saying negative, or that your calculator needs you to put in bottom, negative 2. Okay, I'm putting in negative 2, and then x squared minus 5, x is up here, and then plus 3. All right, I'm going to hit the graph button. I know, that's what I'm thinking, there it is. Vertex, but I don't know exactly what that is. I hit the calculate, second calculum, so scroll down to 4 this time, enter, and then it says left bound, and you move the cursor with the hitting the, there I am left of this vertex, so I hit enter, and then I scroll to the right, I am that vertex, I hit enter a third time, there it is. Maximum is x is negative 1.25, y is 6.125. Okay, my vertex, negative 1.5, and then positive 6.125. Again, I'm labeling this h. That's my vertex. The axis of symmetry, x equals h, which is negative 1.25. The max or min, we know it's a max because it's going down. So a is negative, a less than 0, concave down, domain all real numbers, range. Now if you think about range, it's going down, so y is less than some maximum. Y is less than or equal to which point? K, 6.125. All right, okay, go ahead and try these two problems, and Mr. Raymond will tell you what work to do next. Work hard, and I will see you tomorrow.